Hi, I'm Shaul. One of the most common issues with the concept of dimensionality, 3D pop, microgradation, microcontrast, whatever you would like to call it, is that it is not quite measurable. You see a lot of optical characteristics are measurable. It is quite easy to put those variables on a scale where minimum is bad and maximum is good, or vice versa. A good example for that would be sharpness or acutance or resolving power. It's all basically the same thing. What is used to describe it is the modulation transfer function, or MTF. MTF measures the contrast transmitted by an imaging pipeline, mainly the optics. Basically a test chart depicting a range of adjacent black and white lines that go finer and finer, and contrast is measured across those lines. A representation of contrast level of 100, where white is 100 and black is 0. It signifies a full contrast. There are a lot of ways to look at the MTF, but basically a good measure for estimating the resolving power of a lens is to look at what frequency or how thin the lines are where contrast is still 50%, which means white appears as at 75% brightness and black appears at around 25% brightness, to simplify matters. The best lenses can separate between 75% brightness and 25% brightness, where the spatial frequency is around 200 lines per millimeter. That would represent a distance of about 2.5 microns on the surface of the focal plane, the film or the sensor. A resolving power such as this is typical to f numbers of around f5.6 to f8 at the optimal aperture of many lenses. Wide open, the story is different, of course. A good MTF 50 value would be between 60 and 80, which represents resolving power of about 4.5 microns, maybe 4 in the very best, the highest resolving optics available for photography. There is a clear correlation between MTF50, or the resolving power of a lens, and its perceived sharpness. However, dimensionality, let's call it that, is not quite physical or an engineering concept. It's a biological concept. In biology, there is rarely a variable where low is purely bad and high is purely good. In most cases, biology tries to optimize a variable. There's a concept of the Goldilocks values. In fact, when talking about dimensionality, I would say that the goal is to equate it to a biological system, our vision system. Is comprised of the physical attributes of our eyes and our brains, our neurologic system that interprets the output of our eyes into useful information. Something that we should or should not react to. The perception of three-dimensionality is, of course, related to contrast. If we take a sphere and put it under a light source, the more contrast is transferred by the lens, the more three-dimensional it will look. At 0% contrast will look like a circle, entirely flat. At 50% contrast, you will start to see some variation in brightness according to the angle and the distance of the surface vis-a-vis the light source. And at 100% contrast, the shape of that sphere, its three-dimensionality will be quite obvious. The tonal gradation represented here is, of course, at a quite low frequency. There are no small details to resolve. If we add some finer details and superimpose them over that sphere, you will see that the contrast of the fine details appears more prominent than the low frequency contrast. If the high frequency contrast is too strong, too dominant, it will mask the dimensionality of the low frequency objects in the image. Our brains are wired to focus on high frequency details, because this is usually where the most useful, the most important information lies. So even if we take two lenses with the same low frequency contrast, but one of them has a higher acutance or higher high frequency contrast, there will be a difference in the perception of three-dimensionality. Ideally, what we want is a lens that transmits a high level of contrast at low frequency and a lower level of contrast at high frequency, so that the tiny details do not distract from the tonal gradation of larger objects in the. This is how our eyes work. We are not very sensitive to tiny details. They appear somewhat lower in contrast in the real world with our native vision. Let me demonstrate this concept with three different 35mm lenses. I hope that the representation will be convincing enough, though I'm not sure. So let's explore it. The first lens I will shoot with is this Viltrox 35mm f1.8. It's a modern lens, although it is not as sharp as some of the best. But for our purposes, it will serve as a high resolving power lens that it has a high contrast both in the low frequency range and in the high frequency range. So let's see the image it will give us. I'm now shooting with the Viltrox 35mm f1.8. As you can see, it is very detailed. You can probably count the individual hairs on my mustache. This lens is representative of the modern lenses. They are made for the new high-resolution cameras, and they are very good at resolving small detail in high contrast. I will shoot all those lenses at f2 in order to stress them a little bit, to show you the differences between them. At medium apertures, they will all look about the same, but wide open, the more modern lenses will appear sharper, and the perhaps older lenses will appear a little bit softer, especially at the edges of the frame. So this is what the Viltrox 35 f1.8 looks like. Now let's move to the next lens. The next lens is the Light Lens Lab 35mm f2 8 elements. This lens is a replica of the very first Leica 35mm Summicron. It's a sharp lens. It's quite good, but it is considered to be a low contrast lens. You see that original Leica Summicron was made in the 1960s. Color film was not quite popularized yet. It was expensive. Most of the photographers who shot that original lens used it for black and white, so considerations such as color fidelity, chromatic aberrations were not very important. And when you use it on a modern camera, the appearance of the image is a little bit lower in contrast. It's not really soft, but let me show you. The lens shooting me now is that Light Lens Lab 35mm f2. As you can maybe see already, the overall contrast of this lens is a little bit lower. My skin might look a little bit darker as a result. The image might look a little bit condensed, a little bit blocked, a little bit muddy. It still resolves quite well, I believe. Is it more dimensional than what Viltrox produced? Perhaps not. You will not see it immediately. You will need to process the footage a little bit, to open it up, to increase the contrast in the histogram in order to stretch the gradation. If the Viltrox represented a modern lens with high contrast both in the low frequencies and high frequencies, this lens is on the other end of the scale. It has somewhat lower contrast, both in the high and low frequencies. And that is not very conductive for the perception of three-dimensionality. The next lens I would like to show you is this one. It's the Nikon 35mm f1.4 G. It's a lens made for DSLR cameras, and it represents perhaps the culmination of optical evolution. It was introduced in 2010 and was made for a sensor resolution of around 12 to 16 megapixels on a full frame camera. So it cannot resolve sensors of 36 or 50 or 60 megapixels. It has a very good contrast at the low frequencies, but medium or even a lower contrast at the very high frequencies. So it does not accentuate small details like the Viltrox did. And as a result, there is no distraction to the tonality at the lower range of the frequencies. What you see now is the image coming out of the Nikon 35mm f1.4G at f2. As you can see, my face looks quite natural, quite true to life. You can perceive the shape of my head. The tonality looks natural, very similar to what you see with your naked eye. If you sat here with me, this is probably what I would look like. The low frequency contrast transmitted by this lens is quite similar to the one the Viltrox gives you. But unlike the Viltrox, it is less contrasty at high frequencies. So the acutance, the very fine resolution of small details is dumbed down a little with this Nikon lens. It still looks sharp, of course, but it is not as bitey. It's not as contrasty at the very fine detail level. My face might look a little bit darker than it looked when shooting with the Viltrox, but it is not a true difference. It's just that you are less distracted by the very high contrast of fine details. This rendering should replicate more or less what we see with our own eyes. And it lets our brains interpret the textures, the shapes, and the distances in quite readily. We do not have to put too much cognitive effort in order to decipher the image, to evaluate its output in real life terms. It is all there. You can really appreciate the three-dimensionality of the scene, the objects you see in it, although it's only my face. If we put all three renderings side by side, you will see what I mean. I think that the difference in the perception of three-dimensionality is quite striking. To summarize, the problem of representing dimensionality through the optics is not your typical engineering problem. You can't solve it by a simple mathematical equation or a set of equations. It's more of an optimization problem, because your target is not maximizing resolving power or minimizing it. It's finding the correct ballpark of values. It's making the system similar to a natural, biological system that has its own variability in the population. So there is no one singular value that is the correct one. This is why it is so hard to measure dimensionality in objective terms. My solution is asking the viewers what they think, asking them to evaluate dimensionality through their own eyes, through their own neural interpretation. But I believe that would be the correct way to evaluate it, the only valid way. Please let me know what you thought. Did you see any perceivable differences between those lenses? Which one did you like the most? What do you think about measuring dimensionality, or whether it is a true variable or only some oil snake that everyone talks about but cannot be really demonstrated, cannot be measured, and therefore it does not exist. If you like this video, if you would wish to support my channel, please consider buying me a coffee. It's a nice gesture between gentlemen. You will find the link in the description below. Thank you so much for watching, and see you again soon.